If we expand the rendering parameters dialog in the Artlantis preferences, we gain access to the various components behind the preset values for radiosity. Understanding the purpose and effect of these sliders allows us to customize the accuracy and lighting separately for each view. Let's start with accuracy and use this rendering to better explain the meaning of the two parameters. The long-range slider defines a distance in pixels between test points where Artlantis calculates the radiosity. Between these points, the values are extrapolated. As a result, the lower this value, the more test points we have on the overall surface of the rendering. The short-range slider also affects the calculation's precision, but only for close surfaces. In these areas, and some of them appear colored for better understanding, Artlantis will refine the quality of the radiosity shadow with the set processing range. The larger the value, the more accurate the shadow calculation in these territories will be. This facade with indirect light is a good example to test the accuracy settings. This first rendering has the normal preset values for the long and short range sliders. By increasing the number of test points and setting a more important processing range for the short range, we get a clearer image in this next rendering. These are the values for the medium preset. If we set the values for high, the image will be even richer in details, and the reliefs will nicely emerge from the general plan of the facade. Higher accuracy values demand a longer calculation time in Artlantis. Customize these settings always according to your scene, according to the complexity of shapes and figures needing a more precise calculation. For lighting, we have 4 sliders. The default calculation method is called physical camera, and its first 2 sliders are already known from photography. ISO, which defines the sensitivity of the camera, and shutter speed, which represents the length of time the aperture is exposed to light. In our scene, we definitely need to customize the lighting. We will follow the changes of light and shadows on a grayscale image, so let's see how we can fine-tune it. We start with the internal settings. The light overwhelms the room and in some parts burns out the scene. It should definitely be reduced by cutting the shutter speed to half, for example. It's already much better, however. We may need to differentiate the gray tones even more to make the interior more alive. Back to the internal settings to try something else. What if we decrease only the attenuation? The contrast intensifies and the image becomes richer in tones. There are areas with too much contrast, meaning that the set value for attenuation was a bit exaggerated. The final outcome is the combination of these parameters. The shutter speed was lowered, but not as much as in our previous test. The same was lowered in the attenuation. The final image was rendered with these settings plus a bit of tone correction by darkening the light tones only. Back to Artlantis, there is a second calculation method for lighting called the automatic light adjustment. Artlantis applies it as soon as the physical camera is unchecked. The first 2 sliders change into first bounce and next bounce, while the rest remain the same. First, we need to understand the principles behind these sliders. The first bounce slider controls the radiosity power of the light bouncing for the first time onto a surface. It affects all surfaces receiving direct light emitted from a heliodon or any other light source. The direct light is partially absorbed and partially reflected by surfaces until it completely loses power. The next bounce slider controls the radiosity power of all rebounds after the first one. The attenuation slider controls the absorption of light. A low value increases the contrast of the scene, allowing strong shadows. The fourth slider, the color bleeding, controls the transmission of the diffuse color of materials through the reflected light. This rendering was calculated with the interior presets for the automatic light adjustment. To make it brighter, we can increase the power of the direct light, for example. The room becomes much brighter. However, We notice lots of burnouts, and at the same time, the image turns completely black in some areas. Back to interior settings again. We'll increase the next bounces this time. The room turns brighter once again, and as a consequence of the more powerful rebounds, the image becomes flatter with less contrast. To summarize, we need a combination of settings once again, and this will be the final solution. The more important next bounces value will be corrected with a bit faster absorption of light. In conclusion, let's compare the two renderings. This is the scene rendered with the automatic light adjustment, and this is the other image calculated with the physical camera. Notice the outstanding quality difference between the two. The physical camera delivers a higher fidelity of colors and their brightness as well as a better contrast and sharpness. Bring out the best in your scenes with the expert rendering parameters.